Hi, I am Dr. Eli Kolberg from Unlimited Robotics. Today I will talk about connecting resistors in parallel. Resistors are considered to be connected in parallel if the same voltage is connected to their ends. With parallel connection, one side of each resistor is connected to one side of the other resistors, and the second side of each resistor is connected to the second side of the other resistors, as presented in next figure. From the figure, we see that the source voltage is connected to each one of the resistors. It means that the voltage drop on every resistor is identical and equals to the source voltage V. The current I that comes from the source splits among all the resistors, which are also called branches. If resistor values are different, the current flows through each resistor will be different. The current that flows through each resistor is I1 equals V over R1, I2 equals V over R2, I3 equals V over R3, and I4 equals V over R4. If one resistor will be disconnected, the circuit will not be disconnected as was the case with the series circuit. The current that flows through each remaining resistors will not change, since both their voltage drop and their values are not changed. In other words, the current which flows through each resistor depends only on its resistance. The sum of all the currents that flow through each resistor is equal to the total current I coming from the power source. Let's write it. I equals I1 plus I2 plus I3 plus I4. And thus, I equals V over R1 plus V over R2 plus V over R3 plus V over R4. And it equals to V times, in parentheses, 1 over R1 plus R1 over R2 plus 1 over R3 plus 1 over R4. Looking at the current that flows in each branch, I equals V over Ri, where lowercase I is the index. It can be replaced by a number, like I3 equals V over R3. We see that the more resistance value a resistor have, the less current intensity will flow through it in parallel connection. Since the resistance is located in the denominator, and as resistance increases, the current decreases. That is, in parallel connection, the value of the current in each branch is in inverse ratio to the value of its resistance. For example, in parallel circuit with two resistors, I1 equals V over R1 and I2 equals V over R2. V equals I1 times R1 and V also equals to I2 times R2. That means that I1 times R1, which is equal to V, is also equal to I2 times R2. Dividing both sides of the equation by I2 and R1, we get I1 over I2 equals R2 over R1. The current value in inverse ratio with the resistance value. Example 1. 3 resistors with resistance of R1 equals 6 ohms, R2 equals 12 ohms, and R3 equals 24 ohms are connected in parallel to a source with a voltage of 12 volts. What is the value of the current that flows through each resistor, and what is the total current in the circuit? Answer. Substituting the given data in the equation will result in I1 equals V over R1, which in this case is 12 volts over 6 ohm, and it gives 2 amps. I2 equals V over R2, which in this case is 12 volts over 12 ohms, and it gives 1 amps. I3 equals V over R3, which in this case is 12 volts divided by 24 ohms, and it is equal to half an amps. We know that the total current in the circuit is the sum of the individual currents, and so I equals I1 plus I2 plus I3, and in this case it equals to 2 amps plus 1 amp plus half amp, and in total it equals to 3.5 amperes. Example 2. 3 resistors are connected in parallel to a source voltage. The resistance of R1 is 3 times greater than that of R2 and 2 times smaller than R3. The current that flows through R1 is 12 amps. What is the value of the currents that flow through R2 and R3? And also, what is the total current in the circuit? Answer. According to the given data, R1 equals 3 times R2, and we already know that I1 over I2 equals R2 over R1. That leads to I2 equals I1 times R1 over R2, and in this case is equal to 12 amps times 3 times R2 divided by R2, and in total it gives 36 amps for I2. Likewise, according to the given data, R3 equals 2 times R1, and since I1 over I3 equals to R3 over I1, we get that I3 equals I1 times R1 divided by R3, and in this case is 12 amps times R1 divided by 2 times R1, which gives in total 6 amps. The value of the total current that flows in the circuit is I equals I1 plus I2 plus I3, which in this case equals to 12 amps plus 36 amps plus 6 amps, and in total is 54 amps, the current that flows in the circuit. Thank you for being with me. I hope to see you next time. Bye bye.